So today, for day 3 of lesson 2-4, we are going to focus and concentrate on what are called piecewise functions. And piecewise functions are just graphs that typically have holes or breaks in them, and their domain and also the range can have interruptions. So let's go ahead and look at the definition for a piecewise. And a piecewise function is a function that has different rules or equations for different parts of its domain. So you're going to see more than one graph graphed on the coordinate plane in terms of, well, if x is greater than 2, then you're going to use this equation. But if x is less than or equal to 2, then you're going to use this other equation. So it just depends on what it actually looks like. So let's look at a couple of popular examples. So we're going to start off by graphing the absolute value function. So this is y equals the absolute value of x. Technically, you can rewrite this as what's called a piecewise function. So remember that this value x in here could come out to be positive, or it could come out to be negative. So that's why you see the x inside the absolute value signs being brought out as just an x or just a negative x. So let's go ahead and graph what that looks like, and then our boundary point is going to be 0, and this is going to be called your boundary points over here. And so you can see that we're going to look at values for x that are greater than or equal to 0, and values for x that are less than 0. So technically, the way both of these functions are written, and I'm going to use pink for this one. So I'm going to use pink for this function right here. And this is technically y equals negative x. And then for the graph above, right here, this one, this is technically, we're graphing y equals x, positive x. Because remember, f of x is y, so y equals x or y equals negative x. We're only going to graph values for x that are greater than or equal to 0. So I'm going to start with the y equals x, and our starting value here is 0. And because it's equals to, 0 is included in our domain because remember x is our domain. So I am going to plot a point. If x is 0, then y is also 0. So I'm going to plot a closed point at 0, 0. We'll see if my cursor is going to behave. So there's a closed point. Then the next point I'm going to look at that's greater than 0 is 1. So if I plug in 1 into here, if x is 1, y is 1. So that's going to look like point right there. And then if x is 2, because I keep going greater than 0, if x is 2, y is 2. Plot there. And 3, if x is 3, y is 3. And so forth. So I'm going to connect this with a straight line. And so the only values are going to be from here to here, give or take. I might be off a smidgy bit because my graph is that's supposed to be clearly not a very good. That's supposed to be an arrow. There we go. Okay, so that is what y equals x is for any values for x that are greater than or equal to 0. So here's 0. These are the values of x that are greater than or equal to 0. Then we want to substitute in the values for x that are less than or equal to 0. And that's what we have here, less than or equal to 0. We're subbing into negative x because remember what's inside here could be a negative value for x. So if x is 0, because we still have to, even though x is less than 0, we still have to choose 0 because one of my values could be negative 0.000000001, which is really close to the left side of 0. So we have to still have a value at 0, but what value we come up with here is going to have an open circle. All right, so open circle here because there's no equals to, closed circle here because there's an equals to. So I'm going to do this one in pink. So if I substitute in 0 here, the opposite of 0 is still 0. So I'm going to put an open circle at 0, 0 in pink. And so it happens to be closed by that blue closed circle because they overlap. So technically, this ends up being a closed circle. But for our purposes here, this would be an open circle. Then I'm going to go to the left because that's less than. I'm going to substitute in -1. So if x is -1, what is the opposite of -1? +1. So when x is -1, y is +1. And if you think about it, I'm going to put a dot right there. Try to make it a dot. If you think about it, that's what absolute value says. So the absolute value of -1 is going to be +1 because that's how far -1 is from 0. So that makes sense. So then next we're going to go one more step to the left at -2. So what is the opposite of -2? +2. So we're going to go left 2 and up 2. And then we'll do one more. We'll do -3. So the opposite of -3 is +3. And then I'm going to put a straight line through that. Whoops, I missed it a smidge. You have a ruler, I do not. Okay, so that is what the absolute value graph looks like. It's a very popular piecewise function. You could have graphed this without thinking of it as piecewise, but it does work as a piecewise. Then one of the most popular and I guess would be famous piecewise function is called a step function. And a step function, the graph itself is going to look like stair steps. And it essentially pairs every number in an interval with the same y. So like all the values from x from 0 to 1 are going to have the same y. And all the values of x from 1 to 2 are going to have the same y, and so forth. And this is known as the greatest integer function. And you can see that the notation looks a little funky. It's these brackets, and oftentimes when you write it by hand, it looks like f of x is equal to, and it's like these double brackets. So oftentimes it'll look like this as well. And essentially these brackets indicate that we're going to round down to the next number. Well, what does that mean? So I'm going to give you a table of values that I want you to write down. So over here on the left, let's say we're looking at a table of values for x. And we have a -1.99. And then we have -1.1. And then -0.9. And -0.5. So we're getting bigger. And then 0. And let's start skipping some. 0.5. 1. 1.1. And last one we'll do is 1.99. Okay, so those are all the x values we're going to look at. I want you to consider the number line. So just consider just a plain number line. So I'm going to put the number line here, and since our x values basically are between -2 and 2, I'm going to put 0 here, 1 here, and 2 here, -1 here, and -2 there. So what the greatest integer function says is that we are going to round down to the next number. So we're going to round down, meaning going to the left. So if I were to place -1.99 on the number line, so here's -1, and to go to -1.99 is going to put me right about here, almost to -2. So if we're going to round down to the next integer, the closest integer to the left is -2. So when x is -1.99, y is going to be -2. Let's look at the next one. If x is negative 1.1, so here's negative 1. To go negative 1.1, you're going to go a smidge to the left. That's where negative 1.1 would be. You have to round down to the nearest integer. We can't go to the right. We have to always go to the left. So to the left, that would be negative 2. So again, we have two values for x that have the same y. Then look at negative 0.9. So here's 0, and here's negative 1. To get to negative 0.9, it would be almost to negative 1, but not quite. So if this is where negative 0.9 is, then the next integer to the left of it would be negative 1. So with an x value of negative 0.9, you're going to have a y value of negative 1. Then let's look at negative 0.5. I'm going to move this up a smidge so I don't run into my controls here. So negative 0.5 is going to be halfway in between 0 and negative 1. So here's negative 0.5. We have to round down to the closest integer, which would be negative 1. Then we have 0. Well, 0 is an integer, so it's at 0, so we keep the answer at 0 because that is the next closest integer. We don't have to round down for that one. So 0 is 0. And then we're going to look at 0.5. So 0.5 is between 0 and 1. So again, if we're going to round down to the next integer, I'm going to sneeze. Excuse me. I have bad allergies today. All right, we were going to round down to the left. That gets us to 0. Then our next number is 1. So I go to 1. 1 is an integer, so we keep that. We don't have to round down because it is an integer. Then we're going to go to 1.1. 1.1 is a smidge to the right of 1. To round down, we get to 1. Then go to 1.99. It's almost to 2, but not quite. Remember, we're always rounding down, which means to the left, so we still have to go to 1. So we have to go to 1. So note that you have several, you have an interval of x's that all have the same y's. An interval of x's that have the same y. Here's an interval of x's, and so forth. So what does that look like? So for any value, let's just start at 0. So if I'm at 0, I want to go just a smidge to the left of 0. So all of these x values right here that are to the left of 0 will all have a y value of negative 1. So I'll start up at the y value of negative 1, and I'm going to, I think I'll put this in pink. So at the y value of negative 1, I'm going to choose my pointer here. So if this is my y value of negative 1, remember I'm going to start here with an x value of 0. But if I'm here at negative 1, the only x values that are going to have a value of negative 1 according to this, so here's my y values of negative 1, they are between but not including 0. So it's to the left of 0, right? So here I would have at negative 1 in open circle, at 0, and actually let's go ahead and make our graph a little bit bigger so we can actually write on it. So I'm going to start off by making my graph on here a lot bigger. Okay, so keep your table in mind that's next to you. And then I'm going to actually label my points. I'm going to go every 2 points, like this is 0, but this is going to be 1, 2, 3, and 4. So I'm going to go on every other 2 because it's just so small in there. And so this is going to be 1, 2, 3, and so forth. And this will be negative 1. Actually, I want to put it to the right because I'm probably going to end up, I might put these, I guess it won't matter for that one. I'm going to put these to the right. I normally don't, but negative 1. This is a negative 2, and this is a negative 3, and so forth. That's a negative. Okay, and then this is going to be 1, 2, and 3. Okay, so I'm going to start off at my y value of negative 1. So at negative 1, I have an open circle for an x value of 0, because according to our graph, if x is 0, then y is 0. So if I'm over here and I want to graph that -1 value for y, if x is 0, y is 0, so I know for a fact that at 0, 0, I have a closed circle here. I know that for a fact. But if x is, and maybe it'd be easier if we just graphed our nice integer points. So if you go back over here and look at your table of values that we drew, so here is our point of 0, 0, which we just drew a solid point at. Then we also have a point at 1, 1. And then if I did 2, I had to have a point at 2, 2. So let's go ahead and look to see how that might change how we graph this. So I'm going to go ahead and graph my point at 1, 1. There's my point at 1, 1. And then we know that if x is 2, the y value is going to be 2 because those are integers. So you are going to have solid circles at 3 and 3. And we'll stop there. And then we'll go to the left. So if, oh, and I didn't label this. So this would be -1 and -2 and -3. Okay, so if x is -1, y would be -1. That should be a closed circle. If x is -2, y is -2. So that should be a closed circle. And if x is -3, y is -3. But what if x isn't an integer? If x is 0.5, right here, remember that if x is 0.5, it goes backwards to the lowest value. So if x is 0.5, y is going to be 0. So we would have a point here, right? But if x is 1, all of a sudden y jumps up to here. So, but if x is 0.9, you're going to have a value here, right? Really close. You're going to have a point right there. But as soon as you hit 1, your value jumps up to 1. So you're going to put an open circle here and a straight line right through here. Because between 0 and 1 for x, the y value, and not including 1, the y value is always going to be 0. Then think about this one here. As we looked at -0.5, notice that at -0.5, the y value became -1. So at -0.5, the y value is -1. So I should have a closed circle there. And then I'm going to be down here at -1 for any value between here, as long as it's not 0. So you'll kind of start to see a pattern forming. So you should have a straight line there. And you'll start to see that, oh, okay, I should have an open circle here and a straight line there, an open circle here and a straight line there. And so finish the right-hand side. Open circle here and a straight line there, open circle here, straight line there, and then this one would have an open circle here and a straight line there, and it would continue in that fashion. You can see like it's a stair step. It's kind of cool. All right, so let's look at the back of your page. All right, so here's where we're going to get into what I consider more normal piecewise functions for you all. And in this case, we have two different equations. We have y equals -2x plus 3, which is the graph of a line tilted in a negative direction. And then we have y equals x minus 1, which is the graph of a line tilted in a positive direction. But we are going to restrict the domain of this line to only x values less than 2. And we're going to restrict the domain of this line for only x values greater than or equal to 2. There are two different possibilities for graphing this. You could either graph the entire line and then erase the part of the line that is less than 2, or that is not less than 2, or you can do a table of values. So I'm going to do both. I tend to do table of values because it tends to be easier for students. But this happens to be a linear equation, so you know it crosses the x-axis at 3 and has a negative slope of -2/1. So you could go ahead and plot this point. So I'm going to plot a point at 3, right? And then I'm going to go down 2 to the right 1, 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 down 2, and I'm just going to keep going. Or on the other side, I would go up 2 to the left 1, up 2 to the left, up 2 to the left, and so forth. And then I only want values of x that are less than 2. Now, because 2 is our boundary point, I'm going to find out where is x equal to 2. Here's where x is equal to 2. So here's my boundary point right here. We don't want any of this graph over here. This boundary point here at 2 needs to be an open circle because it's not equals to 2. So I'm going to I'm going to erase this circle here, and I'm going to create an open circle right there. Well, it's a really big open circle. And then I'm going to erase all the values that are not less than 2. And then you can connect and go in a straight line in that direction. That's the only part of the graph that is less than 2. So that's one way. So I'm going to erase all of that because that's definitely a possible way that you could do this. And then now, let's see if I can get these to go away. Yep, perfect. Okay, so this is what I think might be easier for most of you. So I'm going to do this in pink, and I'm going to start here at my boundary point. So I've got x and then y equals negative 2x plus 3. So I'm going to do an xy table. And I'm just going to choose a couple of values because then you can start to see the pattern. So I'm going to start with 2. You always start with your boundary point. And then because it's less than 2, I have to go less than 2. So the next number less than 2 is 1, and then 0, and then negative 1. So we're going to stop there. I'm going to go ahead and fill out my graph here. So I've got, or my t-chart. So I've got negative 2 times something plus 3 equals, and then negative 2 times something plus 3, and then negative 2 times something plus 3, and then negative 2 times something plus 3. All right, I'm going to put my values in here. So I've got 2, 1, 0, and negative 1. And so I end up with negative 2 times 2 is negative 4, plus 3 is negative 1. Negative 2 times 1 is negative 2, plus 3 is 1. Negative 2 times 0 is 0, plus 3 is 3. Negative 2 times negative 1 is 2, plus 3 is 5. So I'm going to plot those ordered pairs, and this is going to be an open circle because this does not have an equals to on there. So that ordered pair 2, negative 1 is going to be an open circle. And so positive 2, negative 1. So that's a much better open circle than before. And then 1, 1. And then 0, 3. And then negative 1, 5. And then you can see that the pattern is up to the left 2, so you can continue that. And then we can draw our straight line and put an arrow on the left-hand side. And so that part of the graph right here represents y equals negative 2x plus 3 for values of x that are less than 2. So here are all the values of x that are less than 2. And so this is the only part of that graph that we need. And so sometimes you might want to put down here a dotted line to represent that boundary point of 2, because as you can see, both graphs revolve around that 2. All right, so then the next graph we're going to do is, I think I'll use orange. So I'm going to have an XY table again. Why is that not behaving? Okay. And so I have y equals. This time I have x minus 1. And so I want to start with 2 because we always start with our boundary point. Why am I starting with 2? Because it says x is greater than or equal to 2. And I want to choose values that are greater than or equal to 2. So 3, 4, and 5. And from there, we ought to be able to see a pattern. So I have big parentheses minus 1, big parentheses minus 1, because that's x minus 1. Okay. So then I'm going to substitute in my values. So I've got 2, 3, 4, and 5. And so we end up with 2 minus 1 is 1, 3 minus 1 is 2, 4 minus 1 is 3, and 5 minus 1 is 4. And remember, this is our boundary point, and so according to this, what the equals to, this is going to be a closed point. So I'm going to put the word closed to remind myself to close the circle. All right, so I'm going to put a closed point at 2, 1. So right here is a closed point. And then 3, 2. And then 4, 3. And then 5, 4. And then you can draw a line going infinitely in that direction. And so it's a funky looking graph, and you can notice that there's this little gap right there. But that's your typical piecewise function. In this situation, when x is less than or equal to 2, we're going to use this equation. When x is greater than or equal to 2, we're going to use this equation. And there you have it. That was a lot of fun. So now we're going to look at domain and range. As you look at a piecewise function, and there's 2 of them graphed here, what is the domain and range? Again, it's a spatial perspective. So I'm going to start here on the x-axis, and we are going to walk the x-axis from left to right. And this is going to be our domain. So we are going to use set notation. So our domain is going to equal. We're going to start with our lowest domain value. So I'm looking for any part of the graph that's on the left-hand side, because we go left to right. So because I have this part of the graph over here is going forever to the left and down forever, 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 that means our smallest domain value has to be negative infinity. And in set notation, maybe I'm going to put this down below instead of over there to the right. So D is equal to, we always put parentheses around negative infinity. And then as I keep walking, we get this break right here where you have an open circle and a closed circle. But notice that right here at -1, even though there's not a value here for y at -1 or for x, we do have an x value that has a point at -1. So even though there's this jump in the graph, we still haven't had any break in our x values. We went from -2 being down here, -1, it's not here, it's up here, that's okay. Then keep going, keep going, keep going. We still have a graph up here, but when we reach 2, we drop down here and keep going to the right. We never have an x, there is no x value on this graph that does not have a y value. So because of that, your domain is going to go from negative infinity to positive infinity. Then we're going to look at our range. So our range, we always have to climb from low to high. So you're going to climb up for your range. And so we're going to start low here. And because this graph keeps going infinitely to the left and down, I know that there's a graph all the way down here, and I don't know when it stops. So, whoops. So for my range, my lowest range value is going to be negative infinity. Then as I climb up, there's still a y value here at -1, right? There's still a y value, it's over here. But are there any y values between -1 and 1? Is there any y values anywhere along here? Nope, nothing. Between -1 and 1, there are no y values. So I know that my graph breaks and stops for the range at -1. The question right now is, do we have a y value? Is there any ordered pair that has a y value of -1? And at first you might think no, because there's these open circles. But don't these x values have a y value of -1? There's 3 -1, 4 -1, 5 -1. So the range does include a y value of -1, so we're going to put a bracket because remember that means closed, it includes it. And then we like to use a union for any jumps or breaks in our graph. So we're going to use a U for union, and then we're going to literally jump from here all the way up to our next lowest y value, which is here at +1. So we don't have any y values between -1 and +1. So our next point that begins with a y value is at +1. And because we actually have an ordered pair with a y value of +1, right here, 0, 1, 1 is included. And then we don't go to infinity. We only go up high enough to here at 5, and this is the highest point of our graph at +5. And we do have a y value that includes 5, and so we are going to close that bracket. So this becomes our entire range. You're going to start to see your domains and ranges looking a little bit different. All right, so then let's look over here at this graph. Again, a difference, and I urge you to pause the video and try to find the domain and range on your own for this graph. So pause the video. Okay, so hopefully you already tried this on your own, but we are going to look at the domain first. So I'm going to walk the domain from left to right. That's my arrow. There's my D. And then as we walk the domain, notice that this arrow is going to infinity to the left. So I know I have infinite values to the left. So my lowest domain value is going to be -infinity. 2, I keep walking, walking, walking. I still have x values. Even though I have an open circle, I have an x value at -2, 4, right? Then I keep going, keep going, keep going, keep going, keep going. There's still x's. I come to this circle here. There is an x value of 2, though, here at 2, -3. And I keep going, keep going, keep going. So there is, again, no break in the domain. There is always an x value that has a y value. However, on this one, the range, if you go from low to high, it does have a break. So this is our range, and this one looks a little funky. So as you start here, there's nothing going infinitely down. So our lowest part of the graph is right here at -3. And so our starting value is at -3, and you have to decide, is there any ordered pair that has -3 as a y value? And sure enough, you have it right here. So you have 3, -3, 4, -3, 5, -3. So -3 is included, so you should have a bracket. 2. And then notice that there's no y values between -3 and -2. Right. Since there are no y values between -3 and -2, we can't include that. So -3 is rather a standalone. So you're going to close the bracket there for that interval, because there are, from -3 to -2, I have no y values there, so I can't create an interval. But I can union -3 with my next interval of y values starts, and it goes from here at -2 all the way to +2. So from -2 all the way to +2, I have y values. But notice that because of these open circles, we're going to have open parentheses because there is no ordered pair that has -2 as a y value. At +2, the y value is actually -3, right? Because you have to jump down to here. And same thing here at 2. -2 does not have a y value of 2 because it jumps all the way up to here to 4. But we do have an interval of y values from -2 to +2, but it does not include -2 or +2. And then we have to jump again, and we're going to have an interval starting here at 4, and just like this interval here, that horizontal line, we don't have any other y values other than 4. 4 is our next highest y value, and there's no interval. It's just we have to tack on 4. So we are going to union with just 4 and put 4 in brackets. So that's a weird range, but there it is. Okay, so the challenge here is, can you write the function rule for this above graph right here? So if you want that challenge, go ahead and pause the video and find your function rule and determine if you can write it. And you're going to write it so it looks something like, where is it? Something like this up here. All right, so pause the video, write your rule and restart it and see what you get. All right, so I'm just going to write the function rule here. It's a challenge, and you can just see if you're correct. So it would be f of x is equal to, and since there are 3 parts to our graph, you should have 3 different rules. So this upper part up here is a horizontal line, and so it is going to be basically y equals 4, and then it's only for values of x that are less than or equal to -2. This line right here is the graph of y equals x, and it's only for values of x between -2 and 2. So y equals x, 4. Now, x is going to be less than 2, but greater than -2. And then this last piece right here is a horizontal line going through the y-axis at -3. So it's y equals -3 for x values that are greater than or equal to 2. So if you did that perfectly, kudos to you, good job. All right, so last problem. Oops, I don't know why that one did not stay. Let's get rid of that. Okay, so I'm going to make this a smidge smaller. All right, so as I'm making you sick, sorry. I highly suggest that you try to graph this on your own, but you do want to mail a care package, and this is a word problem, that weighs 2.5 pounds to your friend out of state. The table lists postage for a care package weighing up to 3 pounds. So we've got, basically, if your package weight is from 0 to 1 pound, you're going to pay $2.33. From 1 to 2 pounds, $2.58, and between 2 and 3 pounds, $2.93. So this is going to be a step function. You need to first define and graph the function and then determine how much you expect to pay for the postage. So let's define our x. So x has to be our package weight. So we're going to squeeze that in there, let x equal package weight. Okay, and so we are going to graph this, and in order to graph that, we are going to try to make this a little bit bigger so that we can all see it. All right, I'm going to use these values right here, these values here, and I'm actually going to do a broken graph. I don't normally do a broken graph, but I am for our purposes here. So for our y value, I am going to do a little broken graph that just implies that I didn't go from, when I start at 0 here, my first one is not going to be a normal amount. So I'm going to go from 0, and then right here is going to be $2. That's $2. And then I'm going to go up to here, and that's going to be $2.20, so I'm going to go by 10 cents. I'm only labeling every other one. And then up here is going to be $2.40. And then here is $2.60. And then up here is $2.80. You're like, well, wait. We have to go up to almost 3. That's fine. So I have here, and then here is going to be $3. So I went a little off the graph, but it works. And then, so this is the cost over here. And then over here is going to be your weight of your package. So I'm going to go right here, and that's going to be 1. That doesn't look like a 1. That's going to be 1. And then right here is going to be 2. And right here is going to be 3. So that'll give us a little bit of room. And then that is weight. Okay. So then, make this a smidge smaller so I can get it all in there. And then move it over. All right. So we are going to plot the first one. Let's put this one right here in green. So if our package weight goes from 0 to -1 and or 0 to 1 and includes 1. All right. So right here at 1, so because I know it includes 1, so that's my closed circle. We're going to go all the way up to $2.33. So that gets us all the way up to here's $2.30, and then $2.33 is right about here. So I'm going to put a closed circle there, give or take. There's your closed circle there. And then we're going to have an open circle here where the package weight is 0. And anything in between 0 and including 1 is going to have a price of $2.33. All right, then the next one is going to be this interval. And so I'm going to have my closed circle at 2. So I'm going to go over here at 2. And at 2 we have a package price, or the price for that package weight is $2.58. So almost $2.60. So like right about here we should have a closed circle. So right about here I'm going to have a closed circle, give or take. And then right here I'm going to have an open circle because it goes from 1 to 2 but not including 1, and it does include 2. So anything in between there, not including 1, up to 2 is going to have a price of $2.58. And then finally I'm going to put this one in blue, and then it starts at 3. So from 3 I go up to $2.93. So all the way up to, I don't know, give or take right here. So that's going to be a closed circle. And then at 2 it'll be an open circle. So as you can see, we have this nice little step function. Then we have to determine our package weighs 2.5 pounds. So 2.5 is right here. Go all the way up to here. I'm going to have a price of that $2.93. So therefore, if the package £2.5 pounds, it will cost $2.93. And that's it. All right, so try your worksheet. Let me know if you have any questions.